Oh gosh.
I need a black
And welcome, ladies and gentlemen, in our last look at sine and cosine functions, at least for now, as far as graphing them is concerned. We're going to talk today about translations, so horizontal shifts and or vertical shifts as well. So in order to do that, let's take a look at this here. And we looked at this a little bit the other day in a previous video. But if I add a number outside of the sine function, that results in a vertical shift. And let's see if we can determine what that does. So if I add 1, what does it shift by?
1.
In what direction?
Up and down.
Up. So if d is a positive 1, it shifted up in a positive 1 direction. Okay? Now a little bit trickier. If I add a constant inside the parentheses of the sine function, the is what I said. So if I add 1, what did it do? Let's see, I'll do it again so you can see it move. So from 0 to 1, what direction is it shifting?
Horizontally.
In what direction?
Left.
Left when c is positive, and right when c is negative. Okay? So it's the opposite for the c value. Now let me put it on something like pi. 3.11, close enough. So I shifted it over pi units, so half of its full period, right? And it shifted it that direction. But now watch what happens if the b value is different. And now when I move this, let's have this start at 0-ish. So here b is 2, so that has halved its period, right? And now watch what happens when I shift it. If I shift it over pi, how much did it actually move over?
None. Moves over 1.
1 what?
1 pi.
I think it moved over half of a pi, right? Look at from 0 to pi. Yeah, it shifted over by pi over 2. So it turns out the horizontal shift is in the opposite direction of c, and it shifts by the c over the k, right? So if this was 3, and I shifted by pi, it actually would shift it by pi over 3. So watch this. So here we go. From 0, shifting, pi units.
Can you just type in the number?
And it actually shifts over by pi over 3. Yeah, I think I can. Actually, no, in this case, I've programmed this to be the difference based on a slider, so it doesn't work that way. So, so a couple things we've learned, okay? So if I have y equals a times sine of k theta, I think, what does the book use for letters here? Plus c, man, they are so all over the place with letters. And then ready for this? What do you think they call this one?
D.
I would have called it D. They call it H, which is the most wrong letter to call it. The most wrong. They should have used H for the horizontal and K for the vertical, so it's at least like conic sections. These guys are crazy. What? Like, what? Like, where do they... Who do they think they are?
Math.
Yeah. You choose letters like a bear chooses letters. I don't know why.
Bears don't know letters.
No, they don't. They don't.
But they do know bees.
Oh, they do know bees. So let's see. So what facts do I know about this? So it turns out there is a horizontal shift by c over k units. Okay? And if c is less than 0, it shifts to the right. So if c is negative, it moves in the positive x direction. If c is greater than 0, it shifts left. And if c equals 0, it didn't shift at all. It tricked you. You thought it shifted. So that's kind of a tricky thing, is that you have to divide c by k in order to know what the horizontal shift was. Let's see, the vertical shift is h units. And that one's very similar to when we did conic sections, right? It shifts it in the direction you'd suspect. I'm not even going to have that broken down like that. So those are those shifts. And then, let's see, what else do we know?
You said this is our last unit, right?
That's the plan. And then we know that A affects the amplitude, and K affects the period, is what happens. So, let's do some examples. How about we? I think those are all the primary facts I need to take from it. Your book presents it in a slightly different way, but when was the last time I cared about what they thought? So let's graph y equals cosine of 2 theta minus pi over 2. So label what my variables are. What's A? 1. What is K?
2.
2. What is C? Man, these are...
Negative pi over 2.
Yeah, C is negative pi over 2. I guess I could also define it as minus... I could define this as minus C here and then have C be positive, but it doesn't really matter. And what is H?
H is 0.
0, right, because of the plus 0, the 1 here. Other questions. What's the amplitude?
Amplitude is 1.
Abs 1, which is 1. And what is the period?
2 equals 2 pi over 3.
So it's pi.
Pi, okay. How much is the horizontal shift? Pi over 2 divided by
Over
2. So that will end up being pi over 4 is the horizontal shift. Because I have to take the C and divide by K to figure out the horizontal shift. And is this shifting to the left or to the right? Right. Right.
No, wait.
Because C is negative, right? So yeah.
Wait, so for the H shift, it's pi over 2 divided by...
Yeah, it's C over K units. So that's what I... C over K. So let's graph this. So the amplitude is 1, 1, 1. So let's see. I'm going to have to divide this up into pi over 4 chunks.
Should that be negative 1?
For the amplitude?
Oh, no, for the negative one.
Oh, thank you. Good call, touche. So here we go. So normally the period would happen in pi units, right? Here, but it's shifted to the right. So I'm going to have to figure out what is pi plus pi over 4. Well, we can figure all this out later. So here's pi over 2, right? Here's pi over 4.
That's pi over 6.
What would this be?
Pi over 6.
No, it'd be 3 of these.
3 pi over
1,
4.
2, 3. 3 pi over 4. So this is 4 pi's over 4, and this would be
5 pi over
5 pi's over 4.
That is dumb.
No. So let's see, cosine. The regular cosine function starts at what?
0.
At 1. Now this has been shifted over that many units. Now I could actually graph the regular one first based on the amplitude and period. You could do that. This is what the regular cosine function would have looked like. Maybe I'll even draw that in blue.
Ooh.
So here's the unshifted one. Meow, 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 Meow.
Meow.
Meow. And I'm shifting this over pi over 4 units, right? So every point is being shifted over pi over 4 units. Every point, right? So let's plot those points and figure out where our translated function would be. Do 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 do.
So it just moves over 1.
Oh, pi over 4. Which happens to be one of my tick marks, if that is what you're asking.
Do 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 do.
And then it looks like this would go down and land right here, right? Something like that. So, the purple graph would be my final graph. So, not terrible, is it? Not terrible.
Ugh, I'm so sleepy. What a nap.
Now, actually, another fact about our graph that we could add is the equation of the midline.
No.
Now, previously, we've had the midline right at the y equals 0, right? But what happens to the midline? I don't know if you can actually see it. Let me highlight that and change color. What's a good color, friends?
Red.
Red? Okay.
That's pink.
So there's our midline. And what happens to the midline as I do my vertical shift?
It's more pink.
Right? It moves how many units? Whatever the, well, in this case, D. In our book's example, it's H, because they're crazy. Crazy like a book.
Do you think it's H because of height?
They don't know what they're talking about. They don't know what's up. H and K, those are like vertex. Those are the center of a circle, right? Center of a hyperbola. Come on now, book. So the midline equation is actually y equals h. So whatever your h is, find your midline. Do 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 do. Yeah, the final exam covers everything. From Math 4. The second half, correct? Yeah. Crazy stuff.
Crazy like a math file.
Like a book.
Let's do y equals 4 times the sine of theta over
Wait, what?
2
Wait, why are you shooting
plus
for
pi minus 6. How about?
Okay, so A equals 4.
Yep. Always pick up points by labeling our facts. So a equals
K
4.
equals pi, theta over Z.
No, that's a 2.
Oh.
But k is the thing I multiplied by theta. What by theta? Theta. Theta. What did I multiply theta by in order to get theta over 2? 1/2. Right? So theta divided by 2 is the same as multiplying it by 1/2. What is the value of C?
C is pi. H is negative 6.
Okay, so amplitude?
Amplitude is 4.
What's the period?
Period is
Pi over
2 pi divided by a half
equals
2 pi multiplied by 2 over 1,
4 pi.
4 pi.
Wait is just take all my thunder. You know, I was on a roll, but whatever. I quit! God bless you, sir.
Sneezes.
Go on.
Thank you. So 4 pi is what I get for the period. What about the midline? What's the equation of the midline? Y equals negative 6 in this case. And what is the H shift?
H shift? Oh, H shift is pi over 1/2, which then equals. I don't. How do you figure? Oh, right. Oops.
And in what direction is that shift?
Right.
Left.
How do you know?
It's positive.
So the other one was right, and it was positive.
No, it wasn't. Check the example.
I did, and it's negative.
Or,
It's
sorry,
positive.
not that it was positive, that it's less than 0.
So, and then the vertical shift is 6 down, right? Okay.
That's
So-
a lot of work, man.
Yeah. So trying to graph this now. Now, question, what is my lowest point on the graph? The midline is at -6. -12? No.
-2. See, amplitude's 4, so
That's the highest point on my graph is -2, sorry.
Negative 10.
-10 is the lowest point. How do you find that?
Negative 6 minus 4.
-6 -4 would give me the lowest point. -6 +4 would give me the highest
See,
point.
I was on the right track.
Why?
I just didn't understand.
Because that's the midline, and then it moves up by the amplitude and down by the amplitude.
This stuff is actually not that hard to
So
understand.
that way it'll give me at least kind of a ballpark area to start with. So my whole graph is in the lower half. Right. So I got to go down as far as -10. What should I count by? Whatever. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nope. Darn it. Bleh. Let's see. Oh, how about I divide this in half? So there's -5, and then I'll put 4 lines in between here. And 1.
How do you know that the
2,
vertical shift is 6 down?
4. Because H was -6.
Also, just the opposite.
It's on the outside of the parentheses.
So it's-
In that case, it's the same as
so
the
it should
direction
be-
you'd suspect.
Also, you just said, okay, no.
Yep. And then let's see. The period is 4 pi, right? And I shifted to the left 2 pi. So I want to go out at least as far as 4 pi, and then I'm shifting it to the left. So I might even want to back out as much as 2 pi. Does that sound good? So if this is 4 pi, and then here's 2 pi, and here's -2 pi. Ah, that's bad. -2 pi. There we go. All right. And then we might as well divide those up into. So let's see. So this would be regular pi. This would be 3 pi. And this would be at
Or you can
negative
just
pi.
leave them blank.
Yeah, you could. Because you've labeled enough, I agree. You don't have to label every tick mark. Similar to what I did with the negatives here.
Okay, so...
Okay, so let's graph the midline. Where's the midline?
Is -6.
Okay, so I'm going to use that as a bearing.
So that means that the middle of the thing has to be S.
All right, so that's the average value of this if you want to think about
That
it.
means it has to start at... What does it start at? Sin starts at 0.
Sine starts at 0. Is this a right side up or an upside down one?
Right side up. No. I don't know what you're
Positive 4, so it's right side up, right? If it was negative for the A value, it would be upside down.
Yeah.
So sine starts at 0. Our new 0 is this -6. I'm going to graph the old sine first before the horizontal shift.
The midline is our new 0.
Yep.
Okay, that's confusing.
And then I go up, right? Sine goes up from 0. And how high up am I going to go?
Wait, say that again?
4. So it's going to go up 4 units because that was the amplitude. So from -6 to 4 is
This is
-2.
all weird.
Then it goes down to 0. And then down to -10. Well, actually, that wasn't 0 there. That was -6, whatever. But you see what I'm doing here. So this is the old sine after the everything but the horizontal shift. And then my horizontal shift, I'm shifting 2
Whoa, why
pi
is mine- Oh, oopsies.
to the left, right? Minus 2 pi. And this will be minus 2 pi. That's not to scale at all, but that's okay. So our final version, this one shifted 2 pi over, so that one's over here. This one shifted 2 pi over, that one's over there. This one shifted 2 pi over, that one's here. This one shifted 2 pi over. Well,
You already
sorry,
did
this
that
one.
one.
and this one.
This is all confusing. Not really.
And this is the new location of that, which actually, that,
Circle.
these aren't actually arced curves. They're not circular. So that would be my new result. But actually, I want to point out that my graph, alternate universe style, that would have been the same as y equals -4 sine of, what was the k value? Of theta over 2 minus 6. Why would this be true? Why is that the same graph?
You got me.
Wait, say that
Because it'd
again?
be reversed.
Because check out our blue graph. This is the blue graph right before the horizontal shift. That's the same as if I flipped it upside down, right? Flip this up here and that upside, right? So I could have just changed the a value and not have done a horizontal shift. So that's what's weird is the way with sine and cosine is they can map onto themselves like super crazy style. So there's multiple ways of representing each graph usually.
So wait, why is the same?
Well, because the way it shifted over was in exactly half of a period, so I could have just flipped it, right? If I flipped the blue one, right, this arc would be down here, and this arc would be up here. So I could have just accommodated that flip by making a negative a value rather than doing a horizontal shift.
Gotcha.
Weird stuff. But anyways, so I recommend actually doing all of the transformations except the horizontal shift I do last. But having the midline is definitely helpful. And then knowing that the amplitude, right, that this went up 4, right, down 4. The fact that the period was still -2 pi to 2 pi is 4 pi units. And actually, oddly enough, also because this is a horizontal shift by half of the period, if I subtracted pi, because check this out, what if I shifted this 2 units this way, right? That would have landed and mapped back onto itself as well. So there's actually all sorts of crazy ways I could have had that work out. But anyways, so that's the idea of translations, I guess, if I'm including the vertical and horizontal stretches and smooshes. But good stuff. Thanks for watching, everybody. Bye.